So this is about X marks the spot. How many of you know my form of mapping? Hands up. How many of you is this completely new to? Almost everyone. Wow, right. So I'm going to talk about the origin of how I got into strategy and how I got into mapping. And then I'm going to talk about maps themselves and the patterns that you see from them. And then I'm going to talk about change. And after I've done change, then I'm going to talk about X marks the spot. Because it's the final keynote of this session and of this conference, and I must admit, I've really enjoyed myself. This is the first time I've spoken in Europe physically for about 5 years. I think the last time was actually at GOTO Amsterdam as well. So thank you very much for having me back. Normally, I do everything virtually and online. All right, so the origin. This all started with me when I was working at this company. It was called Fatango, online photo service, about 16 different lines of business, somewhere in the region of 10 million users. Can you hear me clearly at the back, by the way? Perfect, thank you very much. Right, so company was very profitable, growing, doing really well, but it had a problem. The problem was this person, the CEO. Our CEO was completely and utterly useless, didn't have a clue what they were doing, they were making it up as they went along. Now I know this for a fact because I was the CEO. I used to come up with these wonderful statements. This is us in 2004. Our strategy is customer focus. We will lead an innovative effort in the market through our use of agile techniques and open source. And I simply pinched that from another company and changed a few words. So I was very worried that people would rumble that I didn't know what I was doing. So I used to go around listening to other CEOs talking about strategy and stuff like that. And I used to record the words they used. I called them business level abstractions of a healthy strategy, or BLAs for short. So I used to produce these tables, common BLAs. This is about 2008. Digital, disruptive, innovative, collaborative, competitive advantage, ecosystem, open source, blah, blah, blah. If I did it today, what words would you hear? AI, yeah, it's got to have AI, 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 AI. Any other words? NFTs, blockchain, very good. Any others? AI. More AI, yes, absolutely. So what I then did is I created a BLA template. Our strategy is BLA. We will lead a BLA effort of the market through our use of BLA and BLA to build a BLA. I smashed the BLAs and BLA templates together to auto-generate 64 different strategies. Things like, our strategy is customer focus. We will lead a disruptive effort of the market through our use of innovative platforms and data to build a collaborative ecosystem. Oh, fantastic. Number two, our strategy is I can barely say the words, it's that painful. But I sent them around and I got 3 basic responses from people. This is the exact wording from our business plan. I've seen 2 of these used already, and my favorite was, are you for hire? So a friend of mine put this all online. This is many years ago. This is strategy as service. If you ever need a strategy, just type in the URL, give it nothing whatsoever, and it will generate one for you. If you don't like it, simply press refresh. Now, I don't think it's available anymore, but you don't need it. You just do this with ChatGPT now. Just say, what is my strategy? Blah. It'll give you just as much gibberish. So I ended up in a bookshop in Charing Cross. I'd read every book I could find on strategy. I was getting nowhere. And the bookseller, she asked me, had I ever read Sun Tzu's The Art of War? And I went, no. And so she persuaded me to buy 2 different versions of the book. And I'm very grateful for this, because it was in the reading of the second version I noticed a particular pattern. So Sun Tzu talked about 5 factors that mattered in competition. 1, have a purpose, a moral imperative. 2, understand the landscape you're competing in. 3, understand the heavens, the climatic patterns, so how the landscape is actually changing. 4, understand doctrine, principles, how you organize yourself. And 5, understand leadership and gameplay. And I was like, wow, that's really sort of makes sense to me. And then I came across John Boyd. Anybody heard of John Boyd at all? Couple, great. So John Boyd invented something called the OODA loop, a former US Air Force pilot known as the Mad Major. The first O of the OODA loop is to observe the environment. That's what landscape and climatic patterns are about. Then you orientate yourself around the space. That's what principles and doctrine are about. Then you decide where you're going to act, and then you're going to act. And of course, when you act, it changes the landscape as well. So these overlap very nicely. And I thought, wow, I really need to understand the landscape I'm competing in. And that's what got me into maps. So I started reading everything I could find on maps, military history. This is one of my favorite maps. This is the Battle of Thermopylae. So Themistocles, ancient politician, Greek general, had a problem. The Persians were invading. He decided to block off the streets of Artemisium, force the Persians along a coastal road into Thermopylae. It's a narrow pass. Thermopylae literally means hot gates, where a small number of troops could defend against a larger force. Now, there are about 140,000 Persians. The Greeks were independent city-states. In the army, about 4,000 Greeks, including 300 Spartans. That's where we get the story of the 300 from. And I was like, wow, this is fascinating. You see, we can talk about where things should be and all the rest of it. And then I looked at myself. And I started to think, how do I make decisions? And I use something called SWOT diagrams. Does anybody remember those, or does anybody use those? Right. So I created a SWOT for this battle. Strengths: a well-trained Spartan army, high level of motivation not to become a Persian slave. Weaknesses: the E4s might stop the Spartans turning up. A truckload of Persians are turning up. Opportunities: get rid of the Persians, get rid of the Spartans. We're Athenian, we actually hate the Spartans. And the threats: the Persians get rid of us, and the Oracle says a really dodgy film might be produced a few thousand years later. So, what would you use to communicate and determine strategy in battle? A magic framework like a SWOT diagram, or position and movement like a map? What would you use? A map. What was I using? A magic framework. So at that point, I said to everybody in the organization, bring me all your maps. And they brought me loads of maps. They brought me systems maps, mind maps, customer journey maps, strategy maps, just loads of maps. And this is one of the maps. This is a system map for the online photo service. And I took one component, CRM, and I simply moved it across the screen. Let me do that again, bit of magic. There to there. How has the map changed? Not at all. If I took a map and I moved, I don't know, Amsterdam, and put it next to Dover, would that map change? A bit. So why is it not changed here? Well, the answer is because all of these maps had one thing in common. None of them were maps. They're all graphs. So to explain the difference, these 3 images at the top, 3 locations, Nottingham, London, Dover, connected by 2 roads, M1, M2, these 3 images are all identical, and they're all graphs. The 3 images underneath it are all completely different, and they're all maps. Can you see what the difference is? Right. In a map, space has meaning. So you can't simply just move a bit and keep the connections the same and expect the meaning to stay the same. The meaning will change because space has meaning. And this happens because with a map you have an anchor, you have position of pieces, and you have something called consistency of movement. So if I'm going north, I'm going north. If I'm going south, I'm going south. So I thought I'd create that for my own business. So I can't be bothered to do my own business because it was an online photo service. So I've done a cup of tea for you to make life simple. I should have actually done coffee. But anyway, so we start off with an anchor. So we're going to have the business, we're going to have public. We could have put regulators, we could have put shareholders, we could have put a whole bunch of people. But we'll start with the public and business. And hopefully for our tea shop, the public wants to drink cups of tea, and obviously as a business, we need to sell cups of tea. So that's my anchor at the top. Now, a cup of tea has needs as well. It needs tea, it needs a cup, it needs hot water. Hot water needs cold water and a kettle. Kettle needs power. So what I've now got is anchor and position described through a chain of needs. Okay, that's anchor and position. That's a graph. What about movement? Well, movement's a bit tricky. So movement's really easy with geography because if I go from Thermopylae to Thebes, if I walk, it's highly unlikely that Thebes will have moved during the time that I take the journey. If it took me 200 million years to make the journey, then of course, Pangaea, it'd be in a completely different place. But I flew here. And it wasn't a case of we're flying in the plane and the pilot says, sorry, I've got to make a correction, Amsterdam has moved. I mean, Amsterdam was pretty static. Unfortunately, with technology moves around a lot. So if you think about computing, the Z3 1943, when digital computing was new, you go all the way to 2006, we get utility computing with Amazon, it's completely different. So what we need to do is somehow describe movement in terms of change. Now, it took me 9,223 publications, which I had to read all of them, enormous amounts of data analysis, about 8 months solid work to create a graph which gave me 4 labels. Genesis, custom built, product, commodity. So this is how things evolve. So I simply go through my graph, as it is, and I take each component and ask, is it novel and new? As in genuinely novel and new. First time anybody's done this. That's Genesis. Are we in the world of custom-built examples? Do we have products? Is it more of a commodity? And so I put things where I think they should be, and this is a map. And that was the first map, or actually the second map, that I did back in 2005, which is almost 20 years ago. Now, what I'm really doing here is I'm exposing my assumptions to you in how to build a tea shop or whatever it happens to be, in a way that you can challenge it without challenging me. We tell everybody that great leaders are great storytellers. When you challenge somebody's story, you're challenging their leadership ability, which is why they get defensive. If I put my story in a map, you can tell me my map is wrong without telling me I'm wrong. Anything you can see that's wrong with this map you disagree with? Shout out. Kettle, why have I put kettle in custom built? Right, so there's loads of things. You might say you're missing staff for one, or you might say kettle, why is it over here? Surely kettle's more of a commodity. I think the map is wrong. I don't think boss is wrong, I think the map is wrong. We can also do other things because each of these nodes are stocks of capital. Each of the lines are bidirectional flows, so they're exchanges. You give me money, I give you tea, or whatever it happens to be. So we can put metrics on there, which makes the finance people happy. And then, of course, when we go kettle over there, we can see what the cost of that, how it differentiates, how much more income we'll make. But then somebody might go, but we need those custom-built kettles because it's all about brand exclusivity. Well, we can put that on there and we can see what the impact is. Of course, when it comes to brand exclusivity, why is that in custom build? Why is that not a product? How's that? That doesn't make sense. Well, fortunately, we go back to the 9,223 publications. These are just labels for stage 1, 2, 3, and 4. So when we talk about activities as Genesis, custom, product, commodity, we can also map practices, data, and knowledge. In fact, I can pick anyone from each of these stages. So when I'm mapping cultural systems, I will often go concept, emerging, converging, accepted. So I'm going to put those labels at the bottom. And now you go, right, brand exclusivity is an emerging thing, renewable generation, ethical trade, more converging, these are more accepted. That's perfectly fine. Does that make sense? You might still argue where I put things, that's perfectly fine. What you should be saying is, so what? Why does any of that matter? Right, very simple example, insurance company. This was back in 2011, maybe 2012. This is their process flow. Order, compute, servers go into goods in, modify, mount, rack it. They had a bottleneck with modification, mounting, and racking of these servers. They decided to invest in robotics. They'd spent 6 months working on this project. They'd had all these vendors in. They were about to drop several million on doing this. I was asked to have a look. Well, they had all their business case, they had all their process diagrams, they had all their financial figures. I can't go in there and go, why are you doing robots? Because, I'm challenging their story. So I said, could we map it? And they were like, oh, what's the point of that? We spent 15 minutes arguing what was the point of mapping, and then 15 minutes creating the map. And this is the map they created. User needs compute, order server, goods in, rack, mount, modify. Anybody see anything odd in that map? Custom built rack, yes. I said, why have you got rack in custom built? Because we have custom built racks. What are the modifications you're making to servers? They don't fit our racks, so we have to take cases off, drill new holes, add new plates in order to get them to fit our racks. And that's why you need robotics, yes. Do you know what somebody said? Yeah, why don't we use standard racks? Yeah, so literally 15 minutes arguing, 15 minutes producing the map, 5 minutes for somebody to go, why don't we use standard racks? Do we need to modify the servers then? No. Do we need to spend several million on robotics? No. So why do you think they were modifying? Well, the reason why is because they were trapped by past stories. What they'd constantly focused on was improving process flow. If you improve process flow, you would go spend the millions on robotics. What we've got here is evolutionary flow. So what we realize is this thing should be more of a commodity, so we don't need to do this. As soon as they've done that, insurance company, it's 2010, they go compute. Well, they finally realized that was a utility as well. Some of the most common problems I see is organizations, one, who don't understand who their users are, two, don't understand what their user needs are, three, don't understand the components in the supply chain, four, don't understand how evolved the components are, five, focus on process flow and don't even consider the fact that things might have evolved. That's probably the majority of wasteful spending, and it's huge amounts of money that I see. All right, so as soon as you've done that, then you start to learn patterns. This is HS2, high-speed rail, big, heavy engineering project. This is James Finley, former CIO. We wanted to build HS2 in a virtual world. The reason for doing it in a virtual world is if you get it wrong, it's cheaper to dig up a virtual world and get it wrong than the English countryside. So they decided to, first of all, build it in a virtual world. Pretty straightforward. There is the systems graph for doing that. Now, normally in government at the time, and this must have been about 2012 roughly, we would break it into small contracts, we'd hand it off to other people, so we'd group things by the fact they sounded similar. So we'd have like lot 2 user experience, lot 3 back office, lot 4 infrastructure, hand it off to people, outsource it basically. Massive cost overruns, massive failures, all that sort of stuff. So James wanted to do it differently. So he spent a Sunday afternoon and he mapped it out. This is the map. He sent me the map and said to me, right, how do you manage this? Well, for me, this was quite easy, because back in 2005, 2006, my company, we'd gone all agile, all extreme programming, and we quickly learned that it doesn't work everywhere. And we learned that because we had maps. What we learned is that things evolve, and as they evolve, their characteristics change. So over here, this is where agile extreme programming was good because it reduced the cost of change. Over here, this is where Six Sigma outsourcing worked really well because it was all about reducing deviation, and Lean, Scrum, all that sort of stuff worked well in the middle because we're all about learning and reducing waste. So all we had to do was apply multiple methods to our organization. So I just said, James, that's what you do. So just took his map, said, build this stuff agile in-house, off-the-shelf products over here, outsource this stuff to utility providers wherever possible. i.e., no such thing as one size fits all, use appropriate methods. That's what they did, and unlike most of HS2, this ended up in front of the Public Accounts Committee because it was delivered way ahead of schedule, way under budget. Really simple. There's a world of difference. Oh, yes. Yes, unfortunately, every time I do this at an Agile conference, and I say Agile doesn't work everywhere, the general response is burn him heretic. Every time I do this at a Six Sigma conference, and I say Six Sigma doesn't work everywhere, it's generally burn him heretic. Scaled Agile framework, it's always burn him heretic. But anyway, so I'm quite used to this by now, but it's really simple. There's a world of difference between basically using Agile like extreme programming and being Agile, which means using multiple methods at the same time. Now, if we take one of those contracts, I'll take lot 1 engineering. So that was the original contract. If I overlay that on a map, there you are. I can tell this contract's going to fail before we've even signed the paperwork. And the reason why it's going to fail is the stuff on the right-hand side can be specified, but the stuff on the left-hand side can't be specified. It's changing. We don't know what we want. So what we've tried to do is put this in a contract. You can't specify the stuff you can't specify. It's fairly obvious. And if you try to, you're just going to get massive cost overruns over here. Has anybody experienced this before, seen this? Yeah? It's a scam. The consultants love it. If they can get you to sign up to one of these contracts, they know they're going to cream it in terms of cost overruns. It's awful. It's very easy to fix. Okay, so doing this in government, one project alone, we saved about 425 million, about 1.5 billion in its lifetime. Lots of different projects, huge amounts of money, simply by looking at the contracts and understanding the map and using the map to decide what to do. Okay. Once you do that sort of stuff, once you've got a map and you realize different methods, then you start to realize you can use small teams, and then you start to realize if you do use small teams, doesn't matter whether it's finance, engineering, marketing, attitude changes. So there's a difference between engineering over here, which we like to call explorers, and finance over here, and engineering and finance over here, which we like to call villagers, and engineering and finance over here, which we like to call town planners. They're different focuses, different mindsets, different skill sets, etc. They're all engineers, they're all finance people, but it's all different. So I put this structure in place in, 2005, 2006. If you're interested in that, there is a wonderful paper by our intelligence services, GCHQ, called Boiling Frogs, which talks about that structure. There's much better models now. Sorry, Suzanne, just go and talk to Suzanne, who's a wave. If anybody needs any organizational stuff, Suzanne's in the audience. I hope you went to her talk. All right, so how do we learn these patterns? We learn these patterns through what's known as pre-mortem challenge and post-mortem learning. Pre-mortem challenge is where we build the map and challenge what we're going to do, and that's critically important. and then we go and do stuff, and afterwards we sit down with the same map and see what's changed and what did we learn. And that's post-mortem learning. And from that, we learn patterns. And you've already learned one in this room, and I'm just going to prove it to you. This is my self-driving car, all in Elvish. That is a systems graph for a self-driving car, written in Elvish. And the reason why I've chosen Elvish, because to finance, most IT is Elvish, and to most IT, finance is Elvish as well. So I want to cooperate, I want to collaborate with you. So I've given you my systems graph in Elvish. I now want your advice and help. Should we outsource A? Or should we build it in-house? Or should we buy it off-the-shelf product? What do you think? I want to collaborate with you. We're working together. What do you think? A? Outsource? Outsource? Build your own? It depends. It depends on what the right answer is. But this is all we use. Has anybody been in a room with somebody with a systems diagram, something like this, and had those questions about which bits should we outsource, which should we build our own? Did you answer there? If so, you can answer here. A. All right, let me do this again. I'm going to give you this as a map. Should we outsource or build our own or buy off the shelf? A. Oh, more of you now. Right, should we outsource, build our own? B. Okay, it's as simple as that. All right, when it comes to patterns, there are three basic types. There are climatic patterns. These are the rules of the game. There's about 30 of those. They're common economic patterns. Then there's doctrine. These are principles. There's about 40 universally useful ones, things like focus on user needs, understand your supply chain. And then there's the leadership, which is gameplay. There's about 110 different forms of manipulation of the market. Most people are oblivious to all of this. They can't see it because they can't see the landscape. And so we're going to use the climatic patterns to talk about change. So this is compute roughly in 2005. User needs an application built on best coding practice, on a runtime operating system, best architectural practice, on compute as a product. Remember, each of these nodes themselves can be entire maps. You can expand out, you can expand down, etc. So this is quite a high-level view. The first pattern you learn is everything evolves. So in 2005, we knew compute would eventually end up as a utility. I thought it was going to be Google. It was Amazon in 2006. I didn't know it was a friend of mine, Ben Black, who proposed to Jeff Bezos EC2. It was Chris Pinkham and others who built it in South Africa. It was a standalone service. Jesse, who used to be the master of disaster for Amazon, so he ran their data centers, wouldn't allow this EC2 nonsense anywhere near their data centers. Have you ever heard anybody telling you they were selling spare capacity? It's complete nonsense. It's a total standalone service when it was built. But the first thing is everything evolves. That's pattern number one. Pattern number two is past success breeds inertia. I'm not going to teach you 30 patterns. So there are about 16 different forms of inertia that we have to change. Things like a pre-existing business model, pre-existing capital, social relationships. Very simple one. Who was first with a website, Blockbuster or Netflix? Blockbuster, good. Who was first with video ordering online? Blockbuster, well done. Who was first with video streaming experiments? Blockbuster, fantastic. Who went bankrupt first? Okay, so when anybody says Blockbuster was a dinosaur, well, they out-innovated everybody. What happened with Blockbuster? Why did they go bankrupt? Pre-existing business model. Probably many of you won't remember this. These were in the days we used to have something called video cassettes. And when we take them home and watch them, one of the things we forget to do is take them back the next day. and this gave you a late fee, and they made most of their money from late fees. Do you get late fees with downloading digital content? No, so they had a lot of inertia to changing that business model. One thing, I'm just going to ask for a time check because I don't seem to have a clock. How long have I got?
20 minutes.
20 minutes? Oh, that's fantastic. Right, super. Thank you, sir. All right. The next pattern you get is coevolution. So compute becomes more of a utility. When it does, its characteristics change. So it went from something called high MTTR, high mean time to recovery, to low MTTR. So it used to take us weeks and months to get a machine, and then of course when it became a utility, it took seconds. So we went from things like scale up, N+1 for resilience, disaster recovery test. Does anybody remember those things? Capacity planning, all that nonsense. And then that was high MTTR. When it was low MTTR, we could distribute systems, design for failure, chaos engines. We could do things like continuous deployment because we weren't waiting for months for the machine to turn up. So whenever you get a change, something evolves, you always get a new emerging practice. So that's coevolution, very simple concept. Of course, we didn't know what it was going to be called. Andy and Patrick later on called it DevOps. The next pattern you learn is as things evolve, the efficiency enables innovation, so it becomes easier to build higher order systems. And the next thing you learn after that is higher order systems create new sources of value or worth. So compute becomes a utility, you get new practices which give you speed, you get new things like Netflix. Make sense? Good. So the next pattern you learn is you have no choice over evolution. If you're up against others and they evolve, they get speed, efficiency, and value. So there's pressure on you to change as well. As more change, that pressure mounts. That's known as the Red Queen effect. So back in 2008, you could use the map to work out where to invest. We knew we needed to invest in cloud. We knew there'd be a new set of practices. We didn't know what they were going to be called, but we would invest there, and there were going to be things built on top, so we'd invest there. We'd also knew where not to invest. So best architectural practice for compute as a product. That's the stuff we were going to stick away from. The blue areas is where we were going to invest. Now, I ran strategy for a company called Canonical. Have you heard of Canonical? They provide something called Ubuntu. We were 3% of the operating system market up against Red Hat and Microsoft. They had all the engineers, all the money, all the resources. We were tiny in comparison, but we also had a map. And we had some very gifted people. So that's where we attacked. We were 3% the operating system market in 2008. £500,000, 18 months later, we were 70% of all cloud computing. Was anybody involved in cloud in those days? Do you remember it was like suddenly Ubuntu was everywhere? Anybody? Yeah, hands up, good. You were mapped, and thank you, by the way. So, not in a bad way, in a good way. So, yes. 2010, emerging practice got a new name. It got called DevOps. Best architectural practice for compute as a product got a new name, Legacy. Then roughly about 2014, so 10 years ago, runtime, so coding environment shifted to much more of a utility. So that's things like Lambda. And exactly the same thing, it's about efficiency, emerging practice, and new needs. Now this time, back in 2015, we gave the new emerging practice a name. We called it Jeff, only because we couldn't think of a sensible name. Several years later, people eventually gave it a sensible name. I think they called it FinOps or FinDev, or I think it's FinOps, or one of them. But anyway, we knew it would be there. One of the most interesting things about the change of practice, if I go back to this map where I talk about capital flow, if I go back to JeffCon in 2017, what we would talk about was actually we could map capital flow now inside applications themselves. So you could actually tie where the money was going to where the value was within an application. You can read more about all of this stuff in this wonderful book by Dave Anderson called The Flywheel Effect. So back in 2016, where to invest, serverless, the new practices, the new needs being created, where not to invest, all of the stuff which was going to be, behind the inertia barriers, the one at the top, which was going to end up as being legacy. Of course, if you went to a conference and said to people, DevOps, that was great 6 years ago, but it's now heading towards legacy. Kubernetes, you must be kidding. Burn him, heretic. Now what I'm going to do is I'm going to take runtime serverless, I'm going to shift that down to the bottom of the page, get rid of most of the stuff. It was called FinOps, that's right. And that was roughly about 2018. Then what happened is machine learning rapidly industrializing. We started to realize we could combine this and create conversational programming environments. That was back in 2018. And conversational programming environments, just in case you don't know, a wonderful paper by Nicholas Negroponte, Architecture by Yourself. It's all about the process of design is a conversation between multiple designers, sometimes in the heads of many, sometimes just in the head of one person. And the change is that one of the designers is now the machine. So Alexander Simovic, good friend of mine, who mapped this stuff out back in 2018, went and presented this at AWS reInvent. So it's very simple. It was a system that you talk to, and in this case, not just by text, but actually talk to, and it would build you an entire system. So you'd say, I'd want a flight tracking system. It would ask you questions. Do you think you'll need a table database? What sort of information would you want to store? And then it would go and build it all for you. So it was all running using lots of different AIs, which had been trained. So that's roughly where it was 2018. I'm just going to hide coding environment, FinOps, and all that sort of stuff for a bit, focus on this, roll it forward to 2023. Very excitingly, large language models have become more industrialized, and we no longer really talk about conversational programming. We talk about prompts, prompt engineering, and Copilot. It's the same difference. Okay, couple of warnings. The current way of working is very much dominated by text. So it's code. That's the symbolic instructions that we're using. Why is that a problem? This is a map of coherent city transport. Don't worry, I don't expect you to read it. There will be tests afterwards. This was put together by a number of city planners around the world, from Düsseldorf all the way down to Budapest. And what they were looking at was, how do we map out the concept of city transport? And we have city functions and space and ways like roads and rail, means, so walking, cycling, etc. And through this map, what they realized was that virtual was a transportation system. Now, what does that mean? Well, like any other transportation system, it means it impacts every other. So this is from my friends in Budapest. They were really focused on congestion, 50 people in 33 cars, 50 people on a bus, 50 cyclists, 50 pedestrians. And once we mapped it out and they realized virtual is a transport system, they added this, 50 people in virtual spaces. So we've built all these wonderful digital twins of cities, and almost none of them have virtual as a transportation system. It's a bit like missing out roads. It's as fundamental as that. So if you want to reduce congestion, get more people online. Really obvious stuff. But the thing is, we had this conversation on the map, and when we were talking about the map, it's all about objects, relationships, and context. That is the code for creating the map. And when we talk about the code, it's all about rules, syntax, and style. So it's the same thing, but we have two very, very different conversations, whether we're in the world of text or whether we're in the world of images. And you know this yourself, you see it. Who here works in an engineering department? Hands up. Right, keep your hands up if you've got a whiteboard in your engineering department. All right, we have two conversations in engineering. One is on the screen, and one equally as important, if not more important, is on the whiteboard. And the thing is, what we've trained our large language models is the bit that we've captured, the text, because we haven't captured, so we trained it on the end result, not the entire decision process. So our problem at the moment with large language models, with the idea of copilots, is somehow we've got to capture that decision information, which requires us to use large multimodal models if we can get that information in the first place. There's another problem in the fact that we've got tools and prompts and the runtime. Other words for this are medium, as in text or images, and language. Now, what's the problem with that? Well, unfortunately, tools, medium, and language are how we reason about the world outside us. So the medium in terms of language or graphical, the medium in terms of text or graphical, the language that we actually use, and the tools is literally how we reason about the world. So the problem is, if somebody else takes control of this, they are controlling your way of reasoning about the world, which gives us a problem. Either all of the stuff is open source, and I mean all the symbolic instructions, which is not just the code and the model, but all the way down to the training data, which is itself symbolic instructions, because it changes the behavior of the model. Either all of this is open sourced, and unfortunately, if you listen to people, they always tell you open source will lead to the horror of frontier AI, but also a new enlightenment, or we hand over under fear of safety to a group of people to decide how we reason about the world around us. And that is called a new theocracy, which is what we're currently building. So if you want to change this, you're going to have to do several things. First of all, you're going to have to take tools out of the hands of tool vendors. We need tools to follow the same path that servers have done. So we went from servers as pets, where we would name them, turn them into cattle, which is what utility computing was about. We need to do the same with tools. We need to make sure large multimodal models are actually entirely open sourced and based on images as well. And lastly, it would be really nice if we could not forget the lessons that we learned with serverless and FinOps and include those as well, including things like capital flow. So tools as cattle, very quickly. I now work with these people. When I first met them, I thought, no, this is a chap called Tudor Gerber who runs something called Glamorous Toolkit. I thought he was completely bonkers. But Tudor, when I first met him, he has, when I look at most organizations, we may have 2,000 or 3,000 developers. We probably have about 12 to 15 tools that we currently use. Tudor has about 12 developers, and they have about 12,000 tools that they use. And it was just like, you what? Every time they look at a problem, they build a tool for that specific problem. Now that might sound like absolute madness. But it turns out the fastest way to getting to an answer is to build a tool for the specific problem that you're trying to solve, rather than try to kludge every problem into a monolithic tool. And so that's what they've done. And this is known as moldable development. And so normally, when you build things, when we go looking for problems, it's all gut-feel driven, ad hoc. We think we're data-centric, but it's actually belief-based because we think this data is important. Mostly manual views with monolithic tools. What they've done is created composable micro tools and generated views so everything's automated. So when you go looking for a problem, the first thing you do is you start with a hypothesis, you build a model of the environment that you're actually investigating, you inspect through the generated views, and that's how you discover where the problems were. And I've sat and watched them take on problems which other teams have given up within a year and just solve it all within weeks. Terrifying. Anyway, X marks the spot. Number 1, know your users. Number 2, know the details. Did anybody go to Simon Brown's talk on C4? That's good stuff, okay? Understand the components that are involved in what you're building. Number 3, understand what is being considered. It's not enough just to have the components, you've got to think about how evolved those components are. There's a world of difference between Genesis and custom built, even though it's the same thing or same meaning. Compute in the days of 1943 is not the same as compute in 2006. Once you've done that, understand there's no such thing as one-size-fits-all methodology. Whether it's purchasing, finance, or project management, you have to apply multiple. Once you've done that, think about team structures. Think about using small teams around those components which are similar. If you want to know more about that sort of stuff, go talk to Suzanne. Once you've done that and you've got a map, then you start thinking about how everything is evolving. What's going to happen? What's going to change in your space? Where are you going to have inertia to? Once you've done that, you can start talking about where might we want to invest and where should we avoid. Once you've done that, you need to then start challenging all your assumptions. One last thing. Purpose. I do these research groups where I take up to 90 people who are specialists in a particular area, such as healthcare, defense, manufacturing, construction, agriculture. And what we do, they are a sensor network. There could be up to 90 people. We did it for gaming. The first thing I ask them to do is tell me what's important. They give me all these post-it notes, sometimes 100 odd. And then we categorize them into themes, and then we map multiple perspectives from those themes. The reason why we do this is if you send a group of people to map Paris who've never been to Paris before, and they come back with a map and you ask them what's important, they might say Pierre's Pizza Parlor because they mapped it from a perspective of nice places to eat pizza. So what you want to do is map multiple perspectives, then we ask the question of what's important, then we aggregate it aggregate all the results. And what we discover across all these different topic areas is that where you would invest in a system to improve society is not the same as where you would invest for market growth. So for example, in education, if you want to improve society in education, you invest in things like lifelong learning and critical thinking. Whereas the market will tell you it's use of AI in schools. If you want to improve healthcare for society, then it's focusing on patient-reported outcome measures and sharing medical data. If you take the market perspective, it's all about well-being, which there's a huge industry all about, and personalized medicine. So in all of these industries, we found a difference. And so it's always important to remember what your perspective is. Are you there to make money? Or are you there to try to improve society? The two are not the same. So we started off with Origin. I told you how I got into maps. I talked a little bit about the movement and patterns within maps. We talked about change. And finally, I gave you hopefully some useful tips about when you're thinking about a space, focus on the users, focus on the user needs, think about the components involved, how evolved those components are, use appropriate methodologies. Once you've done that, apply common economic patterns, then you can talk about where to invest and where not to invest. Always challenge your assumptions. And at that point, I'm going to say thank you.